Alright, so this is sort of a review. See if you remember. First off, let's fill in what we know for the line. Do we know the beat? What help? Yeah. How about the slope? How do you get the slope? Up 2 over 4, or even up 1 over 2. Reduces to that. So up 1 over 2, so the slope is 1/2. Now what's going to go here?
One is smaller than?
Yeah, it can't be an equal to because the line is dotted or dashed. So it's less than, there you go. I like it. So it's combining the idea of can you put a line together from information? And then can you tell is it above or below? So that, that kind of problem is nice. If you can do a problem backwards and forwards, that means you pretty well understand it. Okay. All right. I think we did. We kind of took a look ahead to radicals, but I want to do one more of these. I don't think we did this one. Why not, Jeff? Because it's all blank. It's a good clue. All right, Jeff. Come on. Try to do that one while I work out my...
Which kind of shoes on myself? Has everybody been able to sign up for their next math course? Okay? If you've... Huh? There's a lot of things I'm not teaching. Because I'm only one me. Aw. Well, I was originally slated to teach Math 90 again next semester, but then Nemi, she's in here when I come in. She's teaching 110 now, and she's not going to teach it next semester, so I took hers. And if you wanted Nemi instead of me, I'm sorry, too bad. But 1 of 3 I couldn't teach out, so I have too many other things to teach. Wow. What do you mean, the way it is here? So that's less than. So that would be down. Now, the X one, it's just very direct. It's going to be just like it would be on a number line, because that's going to be left or right. Yeah. So it's going to be below, right? Less than. Okay.
This was not as bad as it could be, because they already have it solved for me. How do I graph this first dude? Yeah, what's the line intercept for this guy? 2. Slope tells me to go up 1 over 3. You do it, Jeff. There you go. What kind of line will it be? And then I'm going to shade, again, I'm hoping I'm getting some converts away from the test point. Nothing's wrong with it, but it's just more work than you need. If you plug 0, 0, and you get 0 less than 0 plus 2, is 0 less than 2? Yes. y less than, where are the y's smaller than that? Down here. So I'm just going to put a few representative arrows. Let me stop there. You could do like a bunch of these, and then the cross-hatching would be the answer, if you like cross-hatching. Okay. What about x less than or equal to 3? What would x equal 3? What does that look like? What kind of line? Vertical. So it's going to be here. And what kind of line will it be? Solid. And where are the x's less than? Down here. Question. So where do you doubly shade it?
In that area.
Yeah, this little, I like that, in that area. Yes. Well, you're like, how else do you want me to answer to?
So when it's like, when the 3 is on like the x-axis, it's going to be vertical, but if it was y, it'd be horizontal,
Yes,
right?
x equals is a vertical. Y equals something is a horizontal. And just to show you an example of what I mean by math is not all memorization. If you can memorize this, fine. Take up a few spots in your brain, lose those spots for future shit. I'd much rather go, okay, x equals, when I change x, I move left and right. If x has to be a specific thing, I can't move left and right. I can only move up and down, vertical line. I mean, that's what I mean by, if it makes sense, you just do what makes sense. You don't memorize this stuff, you just do what makes sense. Hopeful. Now, if you memorize that, okay, I'm not going to smack you for that. There's so much room in his brain. All right, is that decent for that? Is that okay? I'll take that as a yes. I got this. The amused looks at me. Okay, so let's see what you know about square roots already. Try to do those 6 right there. This is page 204. Page 204. Do those first 6. All right. This is pretty much you know it or you don't.
Yep.
These numbers should look very familiar from our difference of squares days, right? What is the square root of 81?
Now.
I want to point something out to you guys. That symbol, square root, do you know why it is that way? No. Because you don't get to learn a lot of math history, and a lot of you guys are like, that's fine, Jeff. But there's a reason, there's a historical reason, there were some symbols that were used. There's actually a word that was used, and they just took a part of one of the letters and made it into that symbol. So your brain, this is
You know math language. You know that word in math. Yeah, I just said word. That word means, what does it take 2 of to multiply by the inside? You've internalized the meaning of it, right? So there's, for example, there's something called logarithms. Has anybody ever heard of logarithms? Okay.
Yes.
The symbol for a logarithm is log, which sucks. It's a little word. I think that throws people off. But the reason it's hard is because you haven't had a lot of practice with it. You haven't internalized what the word means in English. You've internalized what that means. You barely have to think about it probably because you just know. If I say chair, you don't go, it has 4 legs normally and I put my ass in it. No. You just know, you know what a chair is, right? So when you take your next course, be it 103 or be it 110, when you get to logarithms, just realize it's the same thing as square roots. I'm not used to what the word means. I have to internalize what the word means. So square root of 49 would be 7, because, just to write a little extra stuff because I got room here, because 7 squared is 49. That's amazing, right? Also, it's positive because that's what it's asking me for, the positive root. So what about number 3? Yeah. This is fine. This is not imaginary because the negative is on the outside. That's 13. So that's negative 13. So that's asking you for the negative root. So what are the roots of 169? 13 and negative 13. This one wants the negative one. To be very explicit. What about this dude? Negative 1, same reasoning. What about this guy? 0, 11. What times itself is 0? 0. And then square root of 36. The problem number told you answer 11. Okay, not too bad, right? Not too bad, not too bad. Now here, what about this guy? It can't be 2 because what's 2 times 2? Not negative 4. It's not negative 2. I'm just moving on, see? It's not negative 2 because what's negative 2 times negative 2? Positive freaking 4. Shit. So what's the square root of negative 4? Not real. Again, it's a very unfortunate choice of words. It's because when they first were thought of, people went, what the hell, that doesn't make any sense. And now we know better, but unfortunately the words we used back then have stuck. So students hear that word imaginary and they're like, I knew it. So what about this guy? Yeah, can I do that? No, so that doesn't save it. That negative can't go inside the square root. You have to do inside first, and you can't. So not real. Now if you write down negative 11i, I'm not going to count it wrong, but you don't have to know what the hell I is. And I love talking about I because it sounds like I don't understand grammar when I do it. Now what about number 9? You can do this. Yeah, square root of 9 is 3. Square root of 16 is 4, so it's 3/4. And to check it, what's 3/4 times 3/4? Freaking 9/16. There you go. Okay, maybe. You all right over there? Natural question. Go on. Okay. Oh, here we go. A couple more here. Number 10 is really evil. Not just because there's an X in it. What do you think the square root of X squared is? You're wrong. The reason you're wrong is a really hidden thing. What should the answer to a square root always be? What should always be true about it? Except for the square root of 0 is 0. Every other square root has to be positive. You with me? So if you think the answer to this is X, you're wrong because X might be negative. So what can I use to force it to always be positive? What always makes the output positive? Absolute values. So what's the square root of X squared? The absolute value of X. Let me show you a concrete example. Here's a concrete example of this.
Square root of negative 3 squared. What is negative 3 squared? Yeah. And what's the square root of 9? 3. So is the answer negative 3? No, the answer was the absolute value of negative 3. 3. No?
Yes.
Remember, this. Why do I put absolute value there? Because the answer has to be positive. That's it. That's why. So if inside it was negative 3 squared, the answer to the square root of that is not negative 3. It can't be. The answer to that is the absolute value of negative 3. So what's this then? What do you think? P cubed. I like it. So the absolute value of P cubed. And why does that make sense? Because what's the square root do to something? Cuts it in half. So this is just like factoring the difference of squares. So P6, you would put P3, P3. Why is the absolute value there? Because P cubed might be negative. Got to cover your ass for that fact. So course number 12. All right, slightly more interesting problem. What would the square root of x to the fourth be? I don't need absolute value. Because that squared is already always positive. Okay. And again, if you do this, you're not wrong. It's just unnecessary. All right. What about number 13? Yeah, so these do kill each other. That's nice. Why does it make sense that they kill each other? Because what's the opposite of squaring something? Square rooting something. So they kill each other, but the answer can't be negative, so I make it absolute value of x plus 2. Okay. All right. So, yes?
For number 10, why can't you do that? Oh, I guess you did, and it's just x.
Yeah, I totally did.
Okay.
Yeah. All right. Now this is an interesting question. They kind of give the answer away a little bit. But guys, this is going to become more important when you get to higher level math. We start dealing with more functions. But whenever I ask you what's the domain of the function, you say, well, where could there be a problem? So if I said 1 over x plus 1, what's the domain? Well, what can't happen in something over something? What cannot happen? Bottom can't be 0. So then I go, well, what makes that happen? I'm going to throw that shit out. So what cannot happen inside of a square root? You can't have a negative number. So the inside has to be at least 0. What's the square root of 0? 0. Right? Is that cool? So that's why they start the table at 0, because that's the lowest input you could use. You try to put a negative 1 in there, and it immediately freaks. Right? So go ahead and try to finish that table, and then plot the points you get. Finish that table, and then try to plot the points that you get. I'm going to see what a square root looks like. Uh-oh. I was like, where's my handle? All right. So what's the square root of 0? 0. And this here, they're just trying to say, get your points together. Get your points all together. Square root of 1 is? That's amazing. Square root of 4 is? 2. Square root of 9 is? 3. So now we got points we can plot. 0, 0, 1, 1, 4, 2, 9, 3. So what's it look like half of? Yeah. So it looks like a parabola that fell over, and this part fell out. Exactly. Parabola had a rough night, or good night. Fell over, and the bottom half of it fell out. So why is the bottom half missing? Because by definition, the square root gives me the positive roots. So I'd have to graph, on top of this, I have to graph the negative square root to get the full parabola. And why does it make sense the shape is like a parabola? Because the square root is the inverse of a square. So the graphs are always related for functions that are inverses. It's really neat. At least to me it is. Okay. All right. I think I've decided I'm going to show you a video. So I better turn this off so that YouTube doesn't say, you got copyrighted shit, man.